going for chapter 10, section 1, going for 5 million views here. Adding and subtracting polynomials. So I'm going to, by looking at our input-output table, we can determine whether our equation or function is linear, quadratic, or something else. And again, this only happens when my y values are the same distance apart. Oopsie. I wanted to write. There we go. So my x values are the same distance apart. So again, here in both these input-output tables, my x are the same distance apart. They're all 1 apart. So to get from -4 to -1, I go up by 3. From -1 to 2, I go up by 3. 2 to 5, I go up by 3. 5 to 8, I go up by 3. Since I'm getting the same number each time, and this is my first column of finding the difference, this would be a first-degree equation. Since it's first degree, that also means that it's going to be a linear equation. So just like we worked with this first semester, y equals mx plus b, all linear equations. For the second one, the difference between -4 and -3 is 1. -3 and 0 is 3. 0 and 5 is 5. 5 and 12 is 7. If I continue the pattern, as you can probably see, 1, 3, 5, 7. Next would be 9, then 11. So I'm going up by 2 each time, so I can do this one more time. 1 and 3, a difference of 2. 3 and 5, difference of 2. 5 and 7, a difference of 2. So this would be a second-degree equation. Second-degree equations are going to be quadratic, just like we worked with last chapter. So going to this last one then, I can find the difference between my y values, 0 and 1. Oops, I'll make that a little smaller. 0 and 1 gives me 1. 1 and 8 gives me 7. 8 and 27 gives me 19. Made a mistake one time, don't want to make that again. 64 minus 27 gives me 37. 64 and 125 gives me 61. And then I can do it one more time. 6 gives me 12, gives me 18, and 24. Again, these are all going up by 6 each time, so this is where I'm going to find my pattern. Up by 6, up by 6, up by 6. Since this is my third column, this is going to be a third-degree equation. And third-degree equation is what we're going to call cubic equation. So cubic function or third-degree function, same thing. So again, when we're going through this, so if I want to find out the degree of an individual term of a polynomial, it's just the exponent of whatever the variable is. So x to the second power, the exponent is 2, so it's going to be a degree of 2. X, just a regular x, since it's invisible, we need to know that that is x to the first power, not x to the 0, x to the first power. So x has a degree of 1. To find the degree of a polynomial, it's just the largest degree of all the terms. So this is my polynomial, is 3x squared plus 2x minus 5x to the fourth. The largest exponent of all those terms is going to be negative 5x to the fourth. And so since the biggest degree is 4, that means that my polynomial is going to be of degree 4. Now moving on to this chart, when I have a polynomial of 6, that's going to be a degree of 0 since I don't have a variable. I'm going to call this a constant function. This is going to be like the function x is equal to 4 or y is equal to 4 where x, or our graph is a vertical or horizontal line. This only has one term. Term is something that, you know, how many things I'm adding to one another. So I'm going to call it a monomial. The second equation, negative 2x, is a degree of 1 since it's x to the first, which means it's going to be linear. Again, I only have one term there since it's just negative 2x, that's one term. So it's still going to be a monomial. Ooh, that looks kind of messy, sorry. 3x plus 1 still, biggest exponent is 1, so it's still going to be linear. But now I have two terms, and so it's going to be a binomial. This one, biggest exponent is 2, so my degree is 2, which means it's going to be quadratic, just like we talked about. And I have 3 terms, so it's going to be a trinomial. This one, I have a degree of 3, and so it's going to be a cubic function. Since I have 2 terms, it's going to be a binomial. And then this last one, degree of 4, which is going to be a quartic function. And then since there's 3 terms, it's going to be a trinomial. So we're going to need to know that and memorize that for our test. Some of the things kind of make sense. Number of terms, mono means 1, bi means 2, tri means 3, and then nomial means terms, so on and so forth. Here we go. So again, polynomial, many terms. Poly means many, nomial means terms. When I want to write an equation in standard form, when I place my terms from largest to smallest degree, so largest to smallest exponent. So the example I gave was x to the 4th plus x to the 3rd plus x to the 2nd plus x goes from largest exponent, which is 4, all the way down to the smallest, which 0 has an exponent of 0, because it doesn't have a variable. My leading coefficient is the coefficient of my first term once my polynomial is written in standard form. So again, the example I gave was 3x to the 4th plus 2x squared plus 7x. And so the largest exponent, this is already written in standard form because I go from largest exponent to smallest. X to the 4th is my largest exponent, so the coefficient of that is 3. And so that's why my leading coefficient is 3. I'm going to do this example over here on the left-hand side. Put that in standard form. Again, I'm going to do the largest exponent is negative 3x to the 4th. Again, make sure the sign goes with it. So it'll be negative 3x to the 4th, negative 4x squared, plus 3x. Make sure that if a subtraction sign happens before whatever my term is, that I move it with when I move it into standard form. When I do here, I'm going to add polynomials together. First thing I'm going to do is write it in standard form. Then I'm going to put the polynomials on top of each other and leave a 0 coefficient or a space for terms that aren't there. Again, when I do this, I'm going to write these in standard form first. This first one's already in standard form. The second one, I'm just going to rewrite that 2x squared plus x minus 5. Plus the second one, 5x to the 3rd, plus x squared, plus x, plus 6. I'm going to go ahead and stack these on top of each other. I'm going to move this guy below this, this second one. So I'm going to go 2x squared, plus x minus 5. Then I can just add my columns together because they're like terms. So it'll be 5x to the 3rd, plus 3x squared, plus 2x, plus 1. That'll be my final answer when I add these together. Then the last thing I'll do is I'm going to subtract these polynomials. So I distribute the negative sign, then add vertically just like we did. So again, subtraction is the same as plus and negative. So what I'm going to do is I'm going to change this subtraction sign to plus and negative, and then distribute this negative to each of these terms. So I'm just going to rewrite this, negative 2x squared plus 5x minus 5 plus, then when I distribute a negative sign, it just changes each of these signs. Negative 2x to the 3rd becomes 2x to the 3rd minus 3x plus 7. Each of those signs changed. Then I'll go ahead and stack them on top of each other. I'm going to move this guy over to the other, underneath the other guy. Again, the order doesn't matter since I'm adding now. So it'll be 2x to the 3rd minus 3x plus 7. Again, I have a big hole here, so I can either put a 0 in there, or I can just leave it blank. I'm always partial to leaving it blank. Once I add these together then, so it'll be 2x to the 3rd, minus 2x squared, plus 2x, plus 2. That's my final answer. I'm recording a video right now. And there's your homework. You want to say hi? No, your voice is gone.